So what this video is going to cover is electron configuration, and more specifically the block system of how an easy way to remember the order of these orbitals and energy levels. So you need to print out this that I got from ChemEd many years ago. And you will need, for this discussion, you're going to want to have 4 different colors. I'm going to use pencils. You can use whatever you want. But what I'm going to do is color in different sections of this periodic table to kind of emphasize an order of things that you could do. All right, so first off, we want to label what we call the energy levels over here on the left. So you will see that each row, which is called a period, is labeled 1 through 7, labeled 1 through 7. So pick a color. What you're going to do is color in the first 2 columns of the periodic table. First 2 columns of the periodic table. This is what we call the S block. The S block. And on the first column, put S1. And then on the second column, put S2. Okay. And so that is, you will see all of those have an S in them. And then take that color and color in this one over here. Okay. So you could write in hydrogen and helium. It's the first energy level. It is the most confusing at first. And for this, we have a different coloring system. Find a different color, and then you're going to color in the last 6 columns of the periodic table. This is what we call the P block. So P block, and then label each column P1, P2, P3, P4, P5, and then I'm going to put a little one over here, P6. This helium doesn't do that. So this is what we call our P block, and do realize that down here we have all of the elements filled in already. So that is also considered the P block. Then pick another color and do what we call the D block. These are our transition metals. So pick a different color and color this all in. Now the D block is going to go from D1 to D10, D1 to D10, because you have 5 unique shapes. So each shape or each orbital can contain 2 electrons. So you could have a total of 10 electrons in the D orbital. And finally, your last color, you're going to color in down here. These are your inner transition metals. Okay, this is called the F block. This is called the F block. Now this, I'm not going to label each one. I'm going to just go 1 through 14. These actually belong in row 6 and 7. Okay. You should probably have a real periodic table out for what we're about to do here. But most periodic tables, they kind of give you a clue as the lanthanide econine series where they belong in row 6 and 7, period 6 and 7. So that is always going to be something that you can refer to. All right, so I am going to, I'm also going to label what I call the noble gases over here. So I have helium, neon, argon, krypton, xenon, and radon, because that will come in useful a little bit later on. All right, so I'm going to start with Cl, chlorine, over here. And again, it would be helpful if you have a real periodic table. So chlorine, if I want to do its electron configuration, what I could do is use this block system to kind of say, all right, what is the order, what is the proper order of the electron configuration? So if I start at the top, okay, what I'm essentially saying is the electrons are starting in energy level 1. That is the energy closest to the nucleus. So I could put 2 electrons in the first energy level. Second energy level has an S and then a P orbital. I could put 2 in the S orbital, and I could put a total of 6 electrons in all of the P's. Then I have my 3s orbital. I have 2 there, and then I have a total of 5. So what I labeled on the top here is essentially what is the last electron that is being filled there. I'm going to take a separate sheet of paper, and again, you could put this on your notes or wherever you want to put it. But chlorine, its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So if I look at the top numbers here, all of these will add up to the total number of electrons you have in that atom. And since I gave you no other information, this is chlorine. This is not anything different from that. So this is a lot of writing. Again, it's not that much. But we can use what we call the noble gas configuration and shorten it quite a bit. Because in chemistry, what we care about is what we call the valence electrons. Okay, VE, valence electrons, the outermost energy level. So these electrons here are part of, or can be described as neon in brackets. The brackets are to say that it has the same number of electrons as neon's electron configuration. So I could rewrite chlorine as neon in brackets and then 3s2, 3p5 because it has 7 valence electrons. And those are the electrons that get involved with all of the chemistry. Okay, so that's why we do it that way. So we are going to do noble gas configuration because it's far easier than anything else. So that went in order. Okay, went energy level 1, 2, 3. And this is kind of how it fills the electrons. Well, where it gets interesting is after the 3p. Okay, it then starts to fill what we call the 4s orbital. And then it fills the 3d. So what I'd like you to do is put a little arrow, okay, and write down row number -1. The d orbitals are always what we call one behind the row that they're in. So since this is row 4, 4 minus 1 is 3. So this is still in the 3rd energy level. But using the block system, you fill the s orbital first, then you fill the d orbital. Okay. So I am going to do the electron configuration of iron. Okay, so starting at the top, again, 1s2, 2s2, 2p6, 3s2, 3p6. So I'm going to use argon as my noble gas because when I use the noble gas configuration, I always want to pick the row above where the element happens to be because that is going to be where it's completely filled. So I'm going to go to my piece of paper, okay, and write down Fe is going to start with argon. Okay. All right. So then once I go past argon, now these are going to be what we call our valence electrons. So you go to this 4th energy level. You fill up the 4s. So you go 4s2, then you go 3d6, 3d6. So write down 4s2, 3d6 for iron. Okay. And your Flynn periodic table, by the way, has all of your electron configurations. So if you, as we do more and more of these problems, you will see that the Flynn periodic table has the electron configuration on the top. Now, the one thing I don't like about the Flynn periodic table is they put the energy levels in order of increasing energy. So they put the 3d6 before the 4s2 for iron. I like to write it according to how it is filled. It does not matter to me how you do it, and both are going to be acceptable, but do note that you will see that on the Flynn periodic table. Okay, so let's skip to mercury down here, way down here. Okay, so again, after you fill the 3D, then you're going to fill the 4P. Then you fill the 5S, the 4D, then the 5P. Then it goes 6S. Well, where it gets even more interesting is the 6th and 7th row. You start to introduce the F block. Okay, so this is going to be row number -2 for what number goes in front of the F of for this row and this row. So since this is row 6, it's going to be a 4F, and this is the 7th row, it's going to be a 5F. So if I want to do Mercury's electron configuration, I'm going to start at the row above it, and I'm going to see I have xenon, okay? So I'm going to write down Mercury and xenon. Okay, so using the block system, once I'm past xenon, I always start with the S. So the energy level, wherever you're starting, always starts with the S. So I have a 6s2, then you have a 4f14, then you go to 5d10. So I'm going to write that down. Okay, so I have 6s2, 4f14, 5d10. And that's the electron configuration of Mercury, which you could confirm on your Flynn periodic table. Okay, so let's do one more. Let's do, why don't you see if you could write the electron configuration of lead? Why don't you see if you could do the electron configuration of lead? So for lead, you should have xenon again, 6s2, sorry, 4f14, 5d10, 6p2. So again, if you could do any of those that include the F's, those are going to be probably the most complicated ones that you're going to see. Okay. Again, use your Flynn periodic table to kind of do some extra practice. All right, so the last thing I want to finish up with on this particular video is some of the rules for filling up these configurations, okay? And these I've already put in your notes, so you just want to maybe highlight a couple things if it makes sense. So we have 3 sets of rules called the Aufbau principle, Pauli principle, and the Hund's rule, okay? Aufbau principle says you always start adding the electrons at the lowest energy level first. So that is why we always start at the top of the block system, energy level 1, we always fill those first. The Pauli principle is exclusive. No electrons are going to have the same 4 quantum numbers. Okay, what that means will make a little bit more sense in further lectures. But what it's saying is that every electron is unique. Okay, so it is a unique set of circumstances that each electron is. And Pauli principle also includes the fact that each electron in the orbital must have what we call opposite spin. So what you're going to see some diagrams do for electrons, again, is arrows. You will see that they're pointing up and pointing down to show that they're spinning what we call clockwise, and counterclockwise is a way to kind of imagine it. And finally, Hund's rule, 2 electrons in the same orbital will have opposite spins to minimize repulsion, okay? And that's going to be, again, key for a couple things that we're going to talk about with electrons. And you always fill one level before moving to the next, and these opposite spins actually attract. So when I'm filling up a 2s and I'm filling up a 2p orbital, I must fill up the 2s first before I go start to fill up the 2p, okay? So I can't just take an electron and start to move them wherever I want. So you fill up an orbital and then you move on to the next one. Then you move on to the next one. Also, when you are talking about a p orbital or a d orbital or an f orbital, you always want to fill an electron one at a time, okay? So what I equate this to is, if you have siblings at home, everybody wants their own bedroom. So each electron is going to fill up one of the px, py, pz, and then you're going to start to see doubling up. So if you have 4 electrons, that would be how the configuration looks.